Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you, good evening Subrajit, good evening Ikra. I hope all of you are doing well guys. So quickly share this session with all your friends and juniors, those who are preparing for GATE 2023 as well as GATE 2024, because this session is going to be really helpful. And today we are starting compiler design. So this is the first class. Yesterday we have taken one intro class where we discussed the weightage analysis, syllabus and what should be the preparation strategy. But today we are going to cover the concepts. So guys, share as much as you can. Good evening Shashikala. Welcome all of you to this session, and this session is going to be really interesting for all of you because today we are not just going to learn the concepts, also we are going to solve the questions based on it. So quickly share and do like the session as much as you can, and we are going to start just in 1 minute. So let's wait for others to join. hello Divya, good evening, welcome. Okay guys, so yes, so today we are going to cover the compiler basics and the first phase of the compiler, which is lexical analysis. And also at the end of the session, I will be giving you some questions for your homework, okay, so that you can try, you can solve those questions. And in the next class, we are going to discuss first those homework questions, and then we are going to proceed further to our next concept. Fine. Right, so before starting, let me tell you one thing. So here we are going to conduct one workshop, that is how to ace GATE 2023 in first attempt, and that will be taken by our dear Anshul Sir. That is on 8th of May at 12:30 p.m. only on BYJU'S Exam Prep app. Good evening Manoj, good evening all of you. So do register for it. And also we have started this concept capsule series where we are going to provide you a 10-minute short video where you can learn the fundamentals, and also we will be telling you the tricks to solve few questions based on from all the subjects based on those concepts. So this is going to be the schedule. You can see for computer science every Sunday and Thursday you will be getting this concept capsule video, and the timing is going to be 9 a.m. So only on BYJU'S Exam Prep YouTube channel you will be getting that. So guys, do subscribe to BYJU'S Exam Prep YouTube channel so that you don't miss any class of this, any video of concept capsules as well as that we are covering in this series. That's good Divya for you. Good evening Saubhagya. Yes, this Sunday you will be getting that. Okay, fine. So before starting, those who don't know me yet, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience in GATE 2020. I have secured All India Rank 294, cleared ISRO and NAILET exams, mentored more than 1,000 students as of now, and these are my area of expertise: operating system, digital logic, compiler design and computer organization and architecture. Good evening Ayush, welcome all of you to this session. Guys, like the session as much as you can, and also share with your friends so that we can have maximum students and they can take the benefit of this class that we are going to start today. Also, if you want to get the PDF of today's class, you can join this Telegram group. This is the link: CS_by_Anshul_Sir. So this is the link of my Telegram group. You will be getting all the PDFs of my YouTube classes, doubt clearances. If you have any doubt, you can ask your doubts there. And also, if you need any guidance related to your preparation, then also you are most welcome. Everything I will be discussing, Manoj, wait for it. Good evening all of you. Do like the session. So let's start guys. What is compiler? So the first thing, as we are starting this subject, compiler design, so first of all we need to understand what is compiler, right? So compiler is a program that converts the source code into your target code. That is your high level language. Suppose you are writing a program in C programming language, so that is your source code. So that compiler converts the source code into your target code. Target code is your low level code, that is the assembly code. So this is the functionality of compiler. It is a program that converts the source code into your target code, which is your assembly code. So as you can see here, it is a program. This is going to be the definition of it. So here we have this compiler. So source code is here. Source code be anything, maybe in C language, maybe in C++, any programming languages. So we are going to compile that one, and we will be getting the target code, which is our low level code, or you can say it is going to convert the source code into the assembly code. Is it clear? Is it clear so far? If you have any doubt, you can ask your doubts. Okay, so we are going to cover most of the concepts and in lot of detail. So what are the various stages of program execution? Suppose you have written one program in C programming languages, and what are the stages through which it has to go through? Good evening, Kritika. Good evening, everyone. Clear? So now here, if you see, we have this high level code, right? That is your C code. So here we are talking about only C programming language. So here it is C code. So this is going to convert. First of all, we are going to provide this high level code to the preprocessor. Preprocessor is not part of the compiler. So before even giving the source code to the compiler, first we give the source code to the preprocessor. What is the functionality of preprocessor? So let's understand it. Let me just change the color here. Yeah. So what is the functionality of preprocessor? Let's understand it. Suppose we have written one header file here, hash include std or ioh, or let's say we have written something like this, hash define, let's say max 100. Now this is the header file that you are going to write in your C program, right? That is in your source code. So the file inclusion, so whenever you are giving this high level code to the preprocessor, this preprocessor is going to include this one. Whatever is the code of this header file, it is going to include in your source code. So one of the functionality of preprocessor is file inclusion. You can also make your notes while attending the class. That will be really helpful for you, so that you can later on revise. Also, I will be providing the PDF to you at the end of the session in my Telegram group. Now, what is this? Hash define max 100. So, what it is going to do, whenever you are going to provide this high level code to the preprocessor, wherever you have max written in your program, that will be replaced by 100. That will be replaced by 100. So, this is what? This is macro expansion. This is, we have macro, and this expansion will be done by your preprocessor, macro expansion. So wherever you are having max written in your source code, that will be replaced by 100. So these are the two functionalities of preprocessor. Is it clear so far? Yes, Sobhagya, file inclusion and macro expansion is the functionality of your preprocessor. So first of all, we give the source code to the preprocessor, and then it is going to give us the modified source program. So when we say modified source program, that means the file inclusion is done. Also, if we have any macro written in our program, that is also being replaced by their value. Is it clear, everyone? I hope, guys, everything is clear so far to you. So this modified source program we are going to provide to a compiler, and this compiler will generate the assembly language code. This compiler will generate the assembly language code. Clear? Then this assembly language code we are going to provide to the assembler, and this will generate the machine code. This will generate the machine code. So basically machine code is we have 0101. Yes, these are the main functionalities of preprocessor, delete or whatever your name it is. Okay, so this machine code we are going to provide to the linker. First, we are going to provide this machine code to the linker. Now we need to understand what is the functionality of linker. So let's talk about linker now. So suppose in your program, suppose you have a source program and you have divided that source program into two modules, right? We can divide it into two modules. Let's say in one module you have M1 module and you have M2 module. Let's say in M1 module you are using some function F1. Suppose you are calling this function F1 and the definition of this function is present in module M2. Suppose you are calling this function F1 which is present in module M1. The definition of this function F1, it is present in M2. So this linking of the function, that means the linking of all the object modules together to form a single module, that will be done by your linker. This is the functionality of linker. So it is going to link all the external, or you can say it is going to resolve all the external references of the program. Clear? Is it clear so far? So this is the functionality of linker. It is going to resolve all the external references of the program. Clear? Then this linker, it is going to produce this executable code which we are going to provide to the loader, and then finally this loader is going to load that executable code into the memory. That means your main memory, which is RAM, random access memory. So your loader is going to load that executable code finally into the main memory for the execution purpose, so that we can run that code and we can get our desired output. Is it clear, everyone? If you have any doubt, please ask. That is the syntax, Sobhage. That is the syntax. Clear? We don't give semicolon. That is the syntax. Clear? So these are the various stages of the program execution. First we have preprocessor, then we have compiler. After compiler, we are going to give it to assembler, and then linker and loader will generate the final executable code which will be present in the main memory for the execution purpose. Clear? Let's proceed further. Now, as we are discussing compiler design, so the most important the thing we are going to discuss is only compiler, not preprocessor, assembler or linker loader. That is not that much important. Here we are going to discuss compiler. So let's talk about various phases of compiler. Exactly, that is correct. So let's talk about phases of compiler. So the first phase, so here we have the modified source program, or you can say just source code, right? So this source code we are going to provide to the first phase of the compiler, which is your lexical analysis phase. What it is going to produce, it is going to produce the stream of tokens, or you can say token stream. I will tell you what is token, everything I will be discussing, don't worry as of now. So we are providing this source code to our first phase of the compiler, that is our lexical analysis phase. It is going to generate the token stream. So source code, or you can say character stream as well. That means whatever you have in your C program, if we are talking about C programming language, whatever you have in the C program, that is going to generate the token stream. Clear? That means the stream of tokens. Then this stream of tokens we are going to provide to the second phase of the compiler, that is your syntax analysis phase. Hi De Villiers, good evening. So your syntax analysis phase will produce what? It will produce the parse tree. It will generate the parse tree for that stream of tokens that it is getting from the lexical analysis phase. Then this parse tree we are going to provide to this semantic analysis phase, and it is going to generate what? Annotated parse tree. You can write APT in short, or you can say semantically verified parse tree. Semantically verified parse tree or annotated parse tree is the same thing, just the different name, right? So this annotated parse tree or semantically verified parse tree we are going to provide to the next phase of the compiler, which is intermediate code generation phase. Now this phase is going to generate the intermediate code. So we can write here, it is going to generate the intermediate code. We can have various types of intermediate code. We will be discussing that whenever we are going to talk about ICG phase separately in this series. Today we are just going to talk about the compiler basics and the lexical analysis phase. Clear? So this intermediate code we are going to provide to the next phase of the compiler, that is code optimization. Now understand carefully that we have two types of code optimization. One is machine independent and other one is machine dependent. Now when we talk about machine independent, we also call it as local optimization. That means it is not dependent on machine. So we have two types of code optimization. Whenever we talk about code optimization after intermediate code generation, that is machine independent. That means it is not dependent on the machine. But we can have, after this last phase of the compiler, that is target code generation, we can have one more phase of code optimization, which is machine dependent. Why so? Because target code generation, it is going to produce the assembly language code, and there we can perform this machine dependent code optimization. But again, it is optional whether we want to perform that or not. Is it clear so far? If you have any doubt, please ask. Anyone? Clear? So we have this intermediate code. So we are providing this intermediate code to the code optimization phase, which is going to generate the optimized intermediate code. Which is going to generate the optimized intermediate code, and finally we are going to provide to the target code generation phase, which is going to generate the assembly language. Clear? Clear? No de Villiers. Machine level language is different, assembly language is different. When we talk about assembly language, so that means if we are loading like load and store instructions that we see in computer organization as well, right? So we can write here memory, let's say 1000. So this is a load instruction. So this is what we have as assembly language. When we talk about machine level, or you can say machine code, basically machine code, so that is the combination of zeros and ones which a human cannot understand, only the machine can understand. Is it clear, everyone? Guys, keep liking the session if you haven't liked it yet. So these are the phases of the compiler. Now we have one data structure, that is your symbol table. So what is the functionality of this data structure symbol table? So whenever we talk about this lexical analysis phase, this is going to identify the tokens. So in tokens we have the identifiers. We will be talking about what are the types of tokens. So here when we talk about identifiers, the information related to the identifiers will be stored in the symbol table. And now what kind of information it is going to store? It is going to store the type of the identifier, whether it is integer type, character type, and so on. It is going to store the scope of the identifier, also the line number, the you can say the declaration line number, everything, all the details of those identifiers, it will be storing into that symbol table, which is a data structure that we maintain, and every phase of the compiler it is going to access that symbol table. Now every phase of the compiler is going to have some different functionality. Lexical analysis phase is using that symbol table to store the information related to identifier. Syntax analysis it is going to store some other information related to that identifier. Clear? Semantic analysis will be storing the type of the identifier, whether it is integer type, because type checking is being performed in the semantic analysis phase. Clear? And then we have intermediate code generation, code optimization, target code generation. These three phases will be accessing the information that is being stored in the symbol table by the above three phases of the compiler. Is it clear so far? Is it clear? So this is the data structure that we maintain, and every phase of the compiler it is going to access that symbol table. Now there is one more thing you need to understand here is the first four phases of the compiler. The first four phases of the compiler, we call them as front end of the compiler. Front end of the compiler. Why we are saying front end of the compiler? Because that is machine independent. If it is machine independent, we are calling it as front end of the compiler. That means you don't have to implement it again and again. Are you getting this point? You don't have to implement these four phases again and again, because that is machine independent. We can use it for any machine. Suppose we have, let's say, 5 machines. Suppose we have M1, M2, M3, M4, M5. 5 machines are there, right? And we want to design a compiler, C compiler, for all these 5 machines. So in that case, we don't have to implement these first 4 phases every time for each machine. We don't have to do that, because that is machine independent. So we are calling these 4 phases of the compiler as the front end of the compiler. But if we talk about code optimization and target code generation, even we can ignore code optimization, because code optimization are of 2 types, as we have discussed few minutes back. So if we talk about the remaining phases of the compiler, that comes under the backend. Okay, so that is the backend of the compiler. That is the backend of the compiler. So because that is machine dependent, it is dependent on the architecture that you are using. So if we have 5 machines, so 5 machines will be having different architecture. So we have to implement the target code generation phase for every machine. Is it clear? Any doubt so far? If you have any doubt, guys, please ask. Because now we are going to have questions also, and you have to answer those questions based on the concepts that we are discussing here. Clear? Now there is one more thing. If you notice here, there is one more thing written here. What is that? That is error handler. So when you have lexical analysis phase, if you have any lexical error, we will be talking about what kind of error we can get. So if you have any lexical error or syntax error or semantic error, in that case there is one error handler present here. So you can assume like this. Suppose you are attending this class, live class, and you are making your own notes. Okay, you are making your own notes. Now let's say after this class you are revising or you are solving some question. Now in that case you are getting a doubt. Okay, so if you are getting a doubt, the first thing you are going to do is you are going to refer your notes, your handwritten notes. Clear? So assume your handwritten notes is nothing but the symbol table. So all the information that you have stored here, that is the symbol table. Clear? So your notes is your symbol table. Let's say after accessing the symbol table, still you are not able to resolve your doubt, or your handwritten notes, still you are not able to resolve your doubts. In that case, you are going to approach one faculty. Maybe you can approach me, or you can approach someone else, right? So that you can clear your doubt. So consider that thing as your error handler. If the compiler is going to get any error, maybe lexical, syntax or semantic error, in that case it is going to give that to the error handler. If error handler is able to access the information, resolve that error, it is going to do that. Otherwise it will just throw the error, and then the user, the programmer, has to rectify it. Is it clear so far? Is it clear so far? What is different passes in compiler? We can have one pass, two pass. When we say one pass, that means we are combining all the phases of the compiler. When we have two passes, then we are calling as front end and back end. Is it clear, de Villiers? So these are the two passes of the compiler. Now if you have any doubt, anyone, please ask, because now we are going to have the questions. And here you have your, okay, before that let's understand what is symbol table. So it is, I have already explained you, but let's see. Symbol table is an important data structure created and maintained by compilers in order to store information about the occurrence of various entities such as variables names, function names, objects, classes, interfaces. So variables, if you are using any variable in your program, function in your program, classes, objects, interfaces, all these are nothing but your identifiers. So the information related to the identifiers, how many times we are using it, everything will be stored in that symbol table, which is a data structure that we are maintaining. Clear? The information is collected by the analysis phase of the compiler. Now what is analysis phase of the compiler? Analysis analysis phase of the compiler is nothing but your lexical analysis phase, syntax analysis phase and semantic analysis phase. These three phases we call as analysis phase of the compiler. So the information will be stored by these three phases, and it will be used by the synthesis phase to generate the target code. That means the remaining phases of the compiler, that we have ICG, code optimization, and the last one is your TCG, target code generation, or simply you can say code generation phase. Is it clear, everyone? So this is the functionality of symbol table. Clear? Let's proceed. Now answer this question. Answer this question quickly. Don't take much time because we need to cover a lot of things. I will just wait for first three answers and then I will be proceeding further. Which of the following does macro expansion? As we have covered already, your preprocessor is going to perform the macro expansion as well as file inclusion. Very good, all of you, those who are answering correctly. Let's proceed to the next question. Question number 2. Very simple question. So I have included these questions so that you can be aware of it. यार पता चले कि यार ध्यान से सुन रहे हो नहीं सुन रहे हो क्लास को. That is important. Clear? Yes. So which of the following is the first phase of the compiler? That is lexical analysis phase. Answer this one now. Question number 3. Which of the following phase depends on system? Which of the following phase depends on system? Yes, what do you say? What should be the answer? When we say depends on the system, that means depend on the machine. Carefully answer this. Yes, Shashikala, that is incorrect. Which of the following phase depends on the system? Lexical analysis phase? No, that is incorrect, because it is independent, machine independent. Syntax, machine independent. Semantic, machine independent. When I write code generation, so that means target code generation, which is the last phase of the compiler, not intermediate code generation. Remember this thing. Sometimes they just mention code generation, so it is by default target code generation. Option D is the correct answer. Yes, what should be the answer? Question number 4. Class is not over yet. After these questions, after this question, or yeah, this is the second last question. After that, we are going to start lexical analysis phase and you are going to enjoy it. I can tell you that. Yes, Shashikala, that is correct. Yes, what should be the answer? Which of the following phase produces parse tree as the output? Saubhagya is saying B, De Villiers B, delete C, Ikra B. Okay, let's see this. So which of the following phase produces parse tree as the output, it is saying. And we know syntax analysis phase that generates the parse tree as the output. Very good, very good. Those who have answered this correctly. Ministry of Railways, semantic is not the correct answer. Semantic analysis phase generates the annotated parse tree or semantically verified parse tree, we can say. Okay, not just parse tree. Clear? Fine. Last question for this topic, compiler basics. Then we are going to start lexical analysis and then we are going to have questions based on that as well. If you attend all this, this lecture entirely, never ever you will commit any mistake in these topics. I can tell you that. Everyone. Okay, we are getting the answers now. So which of the component resolves all the external references in the program? As I explained you, linker, that is the functionality of linker only. It resolves all the external references. That means it is going to link all the object modules together so that easily it can refer. Yes, yes, yes. Linker, that is the correct answer. Fine. So let's proceed now. Let's talk about lexical analysis phase. Guys, keep liking the session. If you haven't liked it yet, also share with your friends. Are you really enjoying it or not? Lexical analysis phase. Now, I discussed, a few minutes back that we have the first phase as the lexical analysis phase. And what is the input it is going to take? The input is going to be the character stream, or we can say the source code, right? And the output it is going to generate, that is token stream, or we can say stream of tokens. Now, there are two terms that we need to understand. Now, I'm writing one code here. Carefully say this. Let's say this is the code I have written. Okay, this is the code. Most probably, yes, De Villiers, mostly you will be getting, I can say, or I will be covering all the most important concepts. Okay, so be consistent in attending the classes. Now we have this code, right? Now there are two terms, one is lexeme and one is token. Now whatever I am writing in my source code, that is called as lexeme. That means the actual part of the program. The user is writing a C program or C++ program or any program, source code. Whatever is present in that program, I will be calling it as lexeme. That is the actual part of the program. So here we can say main is lexeme. Then we have this open parenthesis, we have closed parenthesis, we have open braces, then we have this int, right? We have x, we have semicolon, and we have this closed braces here. Everything is lexeme. Everything is lexeme. Okay, you are Nishu. Fine. Right? So this is your lexeme. That is the actual part of the program. Now what about token? Token is the internal representation of lexeme. So here you can say this is main is going to be your token. But what it is? Can anybody tell me? Is it identifier or is it your keyword? What it is? Anyone? Any guesses? When we talk about main, if you know this. Main is what? Main is identifier or keyword? Exactly. Main is your identifier. Main is your identifier. Main is your identifier. No, it is not keyword. See, let me make it clear to you. Whenever we are writing any variable name, whenever we are writing any function name, classes name, objects, interfaces, all these things are nothing but your identifier. Now let me ask one more thing. Tell me, is it identifier or what? I'm talking about this one. Is it identifier or what? Or a keyword? Printf, scanf. What do you say? Identifier or keyword? Yes, everyone. Come on, come on. It is identifier only. Printf is your identifier. Because printf is also a function. That is also a function name, right? That is your library function, right? So it is also identifier, not a keyword, right? So here you have main, that is your identifier. Here you have open parenthesis, closed parenthesis. This comes under your special symbols. Special symbols, clear? Then you have this open braces as well, that is also your special symbol. Integer, what it is? It is a keyword. It is a keyword. Integer is your keyword, clear? Then we have x. X is a variable name, so that is your identifier. That is your identifier. Then we have this semicolon, special symbol. Then we have this closed parenthesis, special symbol. Is it clear? So this you have as lexemes, and these are your tokens. These are your tokens. So instead of writing identifier, we can write ID1, right? Because whenever we are writing the token, we have the name. Apart from that, we write the we have the attribute, we have the token name. So here we have ID, and here we are writing 1, the value associated with that. ID1, ID2, ID3, like this we can write. So here main is your ID1, X is your ID2, int is your keyword, that is K1 we can write like this. Is it clear, everyone? Yes, comma is also a special symbol. Comma is also a special symbol. Clear? So here we have this already explained to you. Here we have lexical analysis phase of the compiler. We are giving source code. We are getting stream of tokens, or you can say token stream. Here we have the symbol table. So it is going to access the symbol table to store the information related to the identifiers. And if it generates any lexical error, if it finds any lexical error, it is going to report it. It is going to report it. Clear? How many tokens? I will be talking about that. Just wait, Ikra. Now, what is the functionality of lexical analysis? Let's understand it. So there are so many functionalities of lexical analysis phase. Yes, to distinguish between different ID, we are writing numbers. Exactly, Nishu, that is correct. Okay? Because otherwise it will not be able to identify it. Now, what is the functionality of lexical analysis? The first functionality is it will identify lexeme in the given input, right? So first of all, it is going to identify all the lexemes present in your source code. That is the actual part of the program. It is going to identify that. Then it will produce token as the output. That is correct. Third one, it will ignore or delete comments and white spaces. Now, if you have any comment, okay, Vishal. If you have any comment present in your program, or the white spaces, the blank spaces, that is going to be, first it is going to identify that, and then it is going to ignore it, or you can say delete it. Clear? So this is also the functionality of lexical analysis phase. Remember this. Fourth one, it will produce lexical error if any. Fifth one, it makes an entry into the symbol table for each identifier. So that we have discussed here. Then sixth functionality is it should scan first character of source code till last. So that means it is going to scan the entire. It is going to scan the entire source program. Okay, source code. The last functionality is very important, that is longest prefix match, and we also call it as maximal munch rule. Maximal munch rule. I will explain this concept. Just wait for a little time. Okay. So longest prefix match is also one of the functionality of lexical analysis phase. Now let's talk about types of tokens in details. Now carefully see this. So the first token we have here is identifiers. Now what can be the identifier? Identifier can be your variable name. So I'm writing here variable name, then function name, and classes objects name, right? Now apart from this, understand one more thing. It can contain letters, letters, digits and underscore. Clear? So your identifier can contain letters, digits and underscore. Apart from this, nothing is allowed. One more thing you need to write here. Let's write here that it should not start the identifier name. It should not start with a digit. It should not start with a digit. Okay, your identifier cannot start with a digit. For example, if I'm writing something like this, let's say int 1 xyz. Clear? So int is your keyword. Leave it. Now I'm talking about this one. Is this your identifier? No, it cannot be the identifier because it is starting with a digit, and that is not allowed. That is not allowed. Yes, Subrajit. Clear? So your identifier cannot start with a digit and it will contain only the letters, digits and underscore. Is it clear so far? Then the next token we have is keyword. Keyword, we can have int, we can have char, we can have float, we can have bool and etc. Double, short, everything. Long. Right? So these are the keywords we have: int, char, float, bool, etc. Now we talk about operators. So operator can be your plus, your minus. Then we can have this this one, multiplication as well, or you can see the pointer one. And we can have this plus as well. We can have minus as well. We can have this one as well. So there are so many. There are so many operators. Clear? Yes. Shashikala, that is also keyword. Let me write for you if anyone is having confusion. For, do, while, all these are keywords. Correct. Then constants or literals. Suppose I'm writing this one. This is a literal, right? Suppose I'm writing this 1, 2, 3. This is a constant value. If I'm writing this, let's say one string, let's say gate. This is a literal. This is a string literal, right? Similarly, we can have this 40 point, let's say 12. So this is a 40.12, that is a constant value. Clear? So, etc. These are going to be your tokens, constants or literals. Then we have special symbols. So we can have this one, open braces, closed braces, open parenthesis, closed parenthesis, square bracket, sorry, not braces. These are the braces, right? And etc. Comma, all these things will be your special symbols. So these are 5 types of tokens we have. Now to remember this thing, you can remember like this in short. Kisko? K stands for keywords, I stands for identifier, S stands for special symbols, C stands for constants or literals, O stands for operators. So this is the easiest way to remember all types of tokens, that is Kisko. Is it clear, everyone? If you have any doubt, please ask. Maza aa raha hai, nahi aa raha hai, everyone? Guys, share karo yaar session ko as much as you can, so that we can have maximum students and they can also attend and take the benefit of this. Clear? So Kisko is all types of tokens. Now let's find out number of tokens. So these type of questions can be expected in your exam. They will be giving you one code snippet and you have to find the number of tokens. So let's talk about this one. Can you tell me how many tokens are there in the first one? How many tokens are present? Quickly, try to guess. It's okay if you answer incorrectly. It's okay, completely fine. But you are going to learn here. Definitely I can tell you that. Number of tokens present in the first example. Saubhagya is saying 9. Delete is saying 4. Subrajit 9. Okay. Anybody else? 9. Shashikala. Okay, let's see this. Int, that is your keyword, K1. X is your identifier, ID1. Comma is your special symbol, right? Y is your identifier 2. Comma is special symbol. Z is your identifier 3. This is your operator, right? And this is your constant, and semicolon is also your special symbol. So how many tokens we have? We can count it easily. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tokens we have. Number of tokens is equal to 9. Is it clear? Let's talk about this one. Second example. How many tokens? Quickly you can answer. So Bhagya is saying 6. Okay. Let's see here. Int keyword, identifier, operator, constant, semicolon, that is a special symbol. So 1, 2, 3, 4, 5, 6. Number of tokens is equal to 6 for second one. What about third one? 1, 2, 3, 4. 4 tokens. What about fifth one? Char, that is a keyword. 2, 3. Now here you have a character literal, right? So we consider it as a single one. And then we have semicolon. So 1, 2, 3, 4, 5. 5 tokens are there. 5 tokens are there. Is it clear so far? Yes, 5 is the correct answer. Ikra, kya kar rahe ho? 4 is not the correct answer, 5 is the correct answer. Clear? Let's proceed now. Tell me, how many tokens in the fifth one? You can answer all, 5 to 9. How many tokens in the fifth one? Yes, guys. Guys, do like the session if you haven't liked it yet, and share as much as you can. Okay, 5, 6, 5, 6. Let's see this. 1. Whenever you have this pointer, you are going to consider this as a single token. Always remember this. 3, 4, string literal, 5, 6. 6 is the correct answer for this one. 1, 2, 3, 4, 5, 6. 6 is the correct answer. Is it clear so far? Let's say I am writing. Acha, theek hai Ikra. Let's say I am writing this one. How many tokens? How many tokens in this one? So Bhagya is saying, acha, 7th wala, okay. What about this one? How many tokens? 6. 1, 2, 3, 4, 5, 6. 6 tokens. 6 tokens here. Yes, that is correct. Let's talk about this one now. Sixth one. 1, 2. Because we know plus and this one. Why we are considering it as a single token? Because it is using the functionality, one of the functionality which is longest prefix match. So what it is going to do, your lexical analysis phase, suppose you have this one. First it is going to scan this one, okay. It will identify, okay, this is an operator, fine. Then it will go further. Right? Now it will identify that you have another operator. Then you have nothing. So this will be considered as your single. Suppose I am writing this one, x plus 1. So that means x is equal to x plus 1, right? So this is your single token. Similarly, this one is your single token. So how many tokens? 1, 2, 3, 4, 5. 5 is the correct answer. Is it clear, everyone? 5 is the correct answer. Now tell me about 7th one. 7th का क्या आंसर होगा? Yes. 7th one. Now carefully say this. 1. Now here you have first equal to, then plus. So this is a single token. Single, and this one. How many tokens? 1, 2, 3, 4, 5, 6. 6 tokens. 6 is the correct answer for this 7th one. Is it clear so far? Error. Kaha? Subrajit, how you can have error? Which one? Is it clear, everyone? Okay. Fine. Now let's talk about this one. And this is not an error. Okay. If I'm writing, let's say this one, carefully see this. What it is going to do? What it is going to do? It is not an error. Remember this. What it is going to do is, it is going to just assign the R value to the L value. Write a program and write this statement. You will never get an error. I'm telling you this. Okay. After this class, you can try to do this. So it is just going to assign the R value to the R value to the L value. That means Y value will be assigned to X. That's it. That's it. This is not X is equal to X plus Y, Manishankar. This is not X is equal to X plus Y. If I'm writing this one, this is X is equal to X plus Y. I hope you are getting this. Both are different. Here you have plus and then equal to. Here you have equal to and then plus. Both are different. Fine. So let's talk about this one. 1, 2, 3, 4, 5, 6. 6. Do you have any error here? Do you have any lexical error here in the 8th one? Anyone? Do we have any error in this 8th one? Yes, guys, quickly do it. We have so many things to do. Tell me, do we have any error here in this one, 8th one? No lexical error, no lexical error, right? Because your lexical analysis phase, it is just going to identify the tokens. Uska aur koi kaam hi nahi hai, right? It is just going to identify the tokens and it is going to identify the comments and white spaces. It is going to ignore and delete it. That's it. Khatam. Clear? So here, this is not an error, but yes, in case of syntax analysis phase, it is going to throw the error because you cannot write this statement. Here, these are the keywords, not the variable name. So this is not allowed. This here you will be getting the syntax error. You cannot use keywords like this. Clear? What about this one? How many tokens? 1, 2. Now here you have comment. So what your lexical analysis does, it is going to identify the beginning of the comment. First it is going to see, okay, this is the beginning of the comment. So basically how it identifies, because of the regular expression that it uses. Because of the regular expression for identifying the comments, for identifying these tokens, all the regular expressions are there. So based on those regular expressions, it is going to identify the tokens as well as the comments. Is it clear so far? So if we have regular expressions, that means it is equivalent to finite automata. If we have finite automata, it is equivalent to regular grammar. Are you getting this point? I hope TOC you have covered these things, at least you know. Clear? All three are equivalent: regular expressions, finite automata, and your this regular grammar. All three are equivalent. So that is why, remember this thing, in case of lexical analysis phase, we need finite automata. We need finite automata. Clear? So that we can scan the, identify tokens and the comments based on the regular expressions we have. Clear? So if we say what kind of machine we use to in the lexical analysis phase, that is your finite automata. It's okay, Vishal. Clear? And also use your change your name, okay? Every time I'm getting confused. So here 1, 2, this is the beginning of the comment. So whenever it identifies the beginning of the comment, it is going to ignore everything. It is going to ignore everything and it is going to find out the end of the comment. And this is the end of the comment. So once it identifies the end of the comment, it is going to ignore all these things. And then it is going to further consider as the token. So 1, 2, 3. Because you have semicolon here, so 3 tokens here. 3 tokens are present here. Is it clear so far? Clear? Fine. Quickly, jaldi se batao. Number of tokens. Everyone. How many tokens present? How many tokens present? Crystal clear? That's good. Also check if any error is present or not. Okay, carefully. Let's say this int keyword identifier, okay, beginning of the comment. So once it finds the beginning of the comment, it will look for the end of the comment, and it is going to ignore everything. It is going to ignore everything. This is the end of the comment? No, ignore everything. Finally, it finds the end of the comment. So it is going to ignore everything. So here the number of tokens will be 1, 2. Only 2 tokens will be there. Only 2 tokens will be there. Is it clear? Yes, Subrajit, your answer is correct. Saubhagya, your answer is correct. Yes, Ikra, now it is correct. Clear? So 2 tokens are there. What about 11th one? 1, 2, beginning of the comment. Ignore everything. But now here if you see, there is no end of the comment. So whenever there is no end of the comment, in that case it will throw the lexical error. So here you have lexical error. And remember one thing, whenever you are having lexical error, no need to count the number of tokens, because that is incorrect statement. You need to correct it first, then you talk about number of tokens. So whenever you are having lexical error, no need to count number of tokens. What about this one? 1, 2, 3, beginning of the comment, okay, end of the comment. 4, 5, 6, beginning of the comment, end of the comment. So 6 tokens are there. 6 tokens are there. 6 tokens. Yes, Ikra, that is correct. क्या हो गया है सौभाग्य? 6 है, ये दोनों एक ही हैं. What about the last one? How many tokens? What about the last one? Simple है तो. Yes, Nishu, if middle of comment there is this one, then how many tokens in question number 10? Okay, here you are saying. Here, should I add this? Are you talking about this one? Nishu, please confirm once. Nishu, please confirm. Are you talking about this one, to add this one here? Yes, 13th one. Okay, let's see. X is equal to 10 के बाद sir. X is equal to 10 के बाद sir. Okay. अगर यहाँ पे instead of this, if we have this one, you are saying. In that case, it is going to see the end of the, it is going to see the beginning of the comment. It is going to ignore everything, and then it will find the this end of the comment. Now it will see again it is this end of the comment, but it will see there is no beginning of this one. So it is going to ignore this. It is going to throw the lexical error. Lexical error in that case also. Clear? Let's say this one. 1, 2, 3, beginning of the comment, ignore everything, end of the comment. So here you have 1, 2, 3. So that means 3 tokens are there. Yeah, 3 tokens are there. That is correct. Clear? Is it clear, everyone? Let me just erase this one, otherwise you will get confused later on. Fine. Right, so let's proceed further. Yes, 2 more examples. Quickly answer this, all of you. Those who have joined just now, guys, do like the session. And if you have missed the initial part, do check that, okay? Semicolon missing, syntax error. Yes, syntax error. Semicolon missing, syntax error. Lexical error को नहीं पता है. The task of lexical analysis is just to identify the tokens. That's it. Semicolon है, नहीं है, it is not having any idea about it. Clear? Right, what about this one? 4th one. This Nishu, आ गया तुम्हारा. 1, 2, 3. Here we are not having beginning of comment, but here we have end of the comment. क्या होगा? Lexical error होगा. Right? Lexical error होगा. We will be having lexical error in this one because there is no beginning of the comment, but we have the end of the comment. Clear? What about this last one? जल्दी से बताओ. What about this last one? 14th we have the lexical error. Ikra, Sashikala, okay, and Saubhagya. What about this one, last one? So here we have printf 1, printf is your identifier. 2, here we have a string literal, so we will considering it as literal because here we have double quotes. So this we are going to consider it as a single token. Then we have this one, this one, this one, this one, this one, this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tokens are there. 9 tokens are there. Is it clear? Yes. Is it clear to all of you? Fine. Quickly answer this now. Few questions are also there. Then I'm going to give you some homework questions. Homework questions basically will be your previous year questions. I want to give you the confidence to each and every student who is attending this class that you can easily solve the previous year questions based on what we are covering here. That is my motive, main motive. You should be able to solve all the previous year questions. D. Okay, let's see this quickly. Which of the following is not a token? Identifier, yes, it is a token. Keyword, operator, kisko? D is the correct answer here. What about this one? Which of the following is recognized by lexical analysis phase? Yes, Saubhagya, what is your doubt? There is no beginning of the comment, but you have end of the comment. In that case, it will throw the error. Saubhagya, clear? Yes, what is the answer? Mani Shankar is saying D, Saubhagya is saying D, Vishal is saying option A, Subrajit option A. Which of the following is is recognized by lexical analysis phase? Token? Yes. Comments? Yes. Comment also first it recognized, then it ignores or delete. White spaces? Yes. So option D, all of these are correct. All of these are correct. All of these are correct. Which of the following is a lexical error? Answer this. Which of the following is a lexical error? Yes, what should be the answer? Very simple. Subrajit is saying option B. Okay. Option B, option B, option B. Which of the following is a lexical error? Is this a lexical error? No, it will be considered as identifier. Identifier. Constant error. Lexical error. Because identifier cannot start with a digit. That is not allowed. Identifier cannot start with a digit, and here you have the lexical error. Which of the following statement is lexically valid? Answer this one now. Which of the following is lexically valid? Answer this quickly. But Saubhagya, I'm getting your doubt here, but there we have star and then this, what do we say, /. We have it together, so it will consider it as the end of the comment. So it will understand, okay, there is no beginning of the comment. I have not seen it. So it will be considered as the error. Clear? Now, which of the following is statement is lexically valid? Carefully see this. This is identifier. Identifier, semicolon, no error. Identifier, keyword, semicolon, no error. This keyword, identifier, semicolon, no error. So all are lexically valid. Option D is the correct answer. Option D is the correct answer. Find the number of tokens. Quickly, guys. Let's do it quickly. Find the number of tokens. Yes, there will be syntax error in the previous question, Subrajit. That is correct. But no lexical error. Clear? Let's say this. Find the number of tokens. 1, 2, 3, 4 and 5. Option B is the correct answer. Option B is the correct answer. What about this one? Number of tokens in the following code. Quickly do it. Option B. Okay, for 5th, 6th. What about 6th question? Find the number of tokens. Subrajit is saying option C, 9. Shashikala, option C, 9. Okay, let's say this 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tokens are there. Option C is the correct answer. 9 tokens are there. What about this one? Kritika, how you are getting 5? 9 tokens are there, na? 1, 2, 3, 4, 5, 6, 7, 8, 9. Always we consider this pointer, or you can say star, as a separate operator. Okay, we cannot combine them. What about this one? Question number 7. Answer this. Let's say this 1, beginning of the comment, ignore everything, end of the comment, and then you have this one. So 3 tokens are there. Option B is the correct answer. What about this one? How many tokens are there? Yes guys, how many tokens? For question number 8. Kritika is saying 3, Shashikala 3. Okay, let's say this. Here you have in, that will be considered as identifier. Beginning of the comment, ignore everything, end of the comment. After that, 2, 3, 4. So A is the correct answer for this question. A is the correct answer for this question. Okay, Divya, is it clear? A will be the correct answer. 1, 2, 3, 4. Answer this one now. Finite automata can be used to identify what? What we can identify using finite automata? Explained you this concept as well, if you have listened carefully. In is identifier because it will consider it as the variable name, right? In is not a keyword, right? Int is a keyword. Okay, it's okay, Kritika, it's okay. So finite automata can be used to identify tokens only. It is not able to identify syntax. For that we use push down automata, or we can see the context free grammar we need. For semantic we need context sensitive language or context sensitive grammar, right? So finite automata is that this machine is able to identify tokens, not the syntax, not the semantic. Clear? Option A is the correct answer. Let's answer this one now, question number 10, and then iske baad we have one previous year question that is a very beautifully framed question. I hope you have also solved that before. What should be the correct answer? Don't know finite automata, it's okay. No worries. Whenever you are going to learn TOC, Vishal, you will understand it. What should be the answer? Which of the following can be used to recognize the tokens in lexical analysis? Finite automata, yes, we can use. Push down automata, yes, we can use, because push down automata is superset of finite automata. Turing machine, yes, we can use. That is also correct because it is the superset of all machines, and here we have all of these as the correct answer. Yes, all of these is the correct answer. Now let's see this last question of today's class. That is a previous year question, GATE 2018 question, and we are going to solve it now. After that I will be giving you the homework questions. All are previous year, but you have to solve them. Okay, so let's solve it. Let's see this question now. A lexical analyzer uses the following patterns to recognize 3 tokens T1, T2, T3 over the alphabet A, B, C. Patterns means the regular expression, we can say. Clear? So we have these 3 tokens T1, T2 and T3. For every token we are having some regular expression. Clear? So here you have A, this question mark, then we have B or C star A. Now understand this. Note that X question mark means 0 or 1 occurrences of the symbol X. That means X can appear either 0 times or 1 time. Note also that analyzer outputs the token that matches the longest possible prefix. This is one of the functionality of lexical analysis phase, that is maximal munch rule. It is going to scan the longest prefix possible. If the string, this is the string given to you, is processed by the analyzer, which one of the following is the sequence of tokens it outputs? So based on the given options, you have to identify which will be the sequence of token it is going to give as the output. It is going to generate. Clear? Okay, let's say this. So here we have T1. So I can write it as this A or epsilon. Yes or no? 0 occurrences. If I get epsilon, that means 0 occurrences. If I get A, that is 1 occurrences. That is the meaning of this statement, right? 0 or 1 occurrences. Then we have B or C. That means we can have B plus C whole star A. Clear? Sir, question विशाल इसलिए समझ नहीं आ रहा क्योंकि आपने TOC नहीं पढ़ा. In TOC we talk about regular expression. So don't worry, just try to understand. Okay, this regular expression you will understand later on, but how we are going to scan it, you will understand in this class only. Okay, just see carefully. Then here we have this one. So it is a B or epsilon. Epsilon means it is going to generate nothing, empty string. Then it is going to generate B. Then we have A or C. So A or C whole star, and then we have B. And what about this one? It is a C or epsilon. Then we have B plus A whole star, and here it is going to have C. Is it clear? It is clear to all of you. Now carefully see this. This is the string. This is the string we have. That is B, B, A, C, A, B, C. This is the string we have. Now carefully see this. Your lexical analysis phase, it is going to first scan this one. It will see B. Now you tell me, can we generate B using T1 token? Can we generate single B? If you carefully see, it is not going to generate B, but this one it can generate first B, right? Because here in place of B plus C whole star, star means I can have 0, 1, 2, 3 like this. So if I consider B plus C 1, in place of star if I place 1, so either I can generate C or I can generate B. So let's say I'm generating B. So that means the first B I can generate using T1 token. Is it clear? The first B I can generate using T1 token. Is it clear? Now, what about T2? Can I generate B here? Yes, using this one I can generate B, B or epsilon. That means I can generate single B. Yes. What about T3? Here also, if I take B plus A raised to the power 1, that means I can generate B here also. That means I can start with either T1, either T2, either T3. I mean either T1 or T2 or T3, right? Now further we have to go because we are using longest possible prefix. If I scan further, I can see BB. Can I generate BB here using T1? Yes, I can generate. If I take 2 here, so I can generate, this is equivalent to what? B plus C, B plus C. So I can generate B from here, I can generate B from here. That means I can start with the T1. What about T2? I can generate B here and B is also here. In place of star, I will place 0. A plus C will become 0. That means empty string. That is epsilon. And here we have B. That means I have 2 B's. So I can start with T2 as well. Is it clear so far? Is it clear so far, everyone? That means I can start with the T2 as well. What about T3? Now here if you see, I can generate B, single B here, right? I can generate and I can generate double B also. If I take this one, B plus A raised to the power 2. So I can generate B plus A, B plus A. That means B and B I can generate. That means still I can start with any of the tokens T1 or T2 or T3. Is it clear? Let's go further. BBA. Now carefully see this. Let's talk about T1. I can generate BBA. BB I can see. I have generated it. And here we have A. That means I can start with the T1 because we have to see longest prefix match. Understand this point. What about T2? I can have B. Fine. I can have another B. But after that, I am not having any A. That means I can ignore T2 option. Because I cannot start with T2 because we are looking for the longest prefix match. And we are getting that from T1. So option C cannot be your answer. Option C cannot be your answer because it is starting from T2 and we are looking for the longest prefix match. Is it clear? Is it clear to all of you? Fine. Now let's proceed. Let's talk about T3 as well. So here we have B. I can generate B again because we have star. Then after that I can generate A from this one. If I take B plus A raised to the power 3. So B plus A, B, let's take B. B plus A, let's take B. B plus A, let's take A. So BBA can be generated. So I can start with T3 as well. I can start with T3 as well. Clear? Let's go further. BBAA. Now let's talk about T1. B I can generate, A I can generate, but after that I am not having another A. Fine, let's talk about T3 now. I can generate B, I can generate another B, I can generate 2 times A as well if I take B plus A raised to the power 4. That means this is going to give me the longest prefix match if it is going to start with T3. So I can ignore all the options starting with T1, yes or no? So that means option A also not possible, option B also not possible. So far we can say. Is it clear? Because T3 will give me the longest prefix match. Is it clear to all of you? If it is clear, yes, yes, yes. Right? So now we can say, let's scan further. B, B, A, C, double B, double A, C, double B, double B, double A, and then we have C also. Fine, let's go further. B, B, A, C, A. Can I generate A after C? No, that is not possible. So that means till this point here we are going to have T3. That means from B till C. From B till C we are getting T3 token. Is it clear so far? Now what about this one? Again it is going to start. Again it is going to start. A. Now after T3 you can eliminate the options. You can clearly answer this question that D is going to be the answer. Right, in the exam you will not take that much time. Here I am explaining the concept, right? If suppose options are not given to you, then what are the possible? So you have to find that as well. But here we have eliminated 3 options. Obviously D is going to be the answer, but let's see how we are getting T3 here. So we have A I can generate from here. Yes, I can generate, or single A I can generate from T1 as well. Then from T2 I can generate A. Yes, I can generate A. From T3 I can generate A. Yes, I can generate A. So that is possible. Let's go further. AB. Let's go further. AB. Can I generate AB from T1? I can generate single A, but after that I am not having B. That means T1 eliminated completely. What about T2? I can generate A, and after that I am having B also. So far we can consider it. What about T3? I can generate A, right? And then I can generate B from here, because B plus A raised to the power 2 if I take, A and B will be generated. So further we can go. ABC. Now ABC. Can I generate from T1? Okay, T1 we have eliminated now. What about T2? ABC. So we can generate A from here. We can generate B from here, but after that we are not having C. So we can ignore this one as well. T2 also we cannot consider. What about T3? So A we can generate, B from here we can generate, and here we have C. So ABC, everything we can generate from this T3. So T3 and T3, that will be the answer. Is it clear everyone? Is it clear so far? Yes, 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 Sashikala and all of you. I will be sharing this PDF with all of you in my Telegram group. I have shared the Telegram group in the beginning of the class. You can go to that again and you can join the Telegram group. Just after the class I will be sharing that, so that you can solve the previous year, this homework questions that I am giving to you. In the next class, that is tomorrow, I will be solving first these questions, and then we will be moving on to the next concept. Clear? So these are the questions you have. Try to solve them. All are previous year questions. I have given previous year questions so that you can get the confidence that yes, you can solve these questions. So that's it guys from today's class, and subscribe to Byjus Exam Prep YouTube channel if you really want to have these kind of classes. And as a faculty, I'm giving my best to give you the best content available, right? And you can also feel so. Clear? Homework question will be there in the PDF, Vishal. You can just join the Telegram group. So you should definitely solve those questions and then come to the next class, that is tomorrow again at 8 PM. I will see you there. Tomorrow we will be first solving these previous year questions, and then we will be starting this first and follow and LL1 parser. Clear? Okay. So that's it from my side. Thank you all of you. Good night. Take care and bye-bye, and do share this session as much as you can with your friends and juniors. Thank you all. Good night. Take care and bye-bye.